And that's how software development works today. Follow me on the screen to get all the details. Alright, we are on FigJam, and as we said in the intro, today we will see how software development works. We will see all the life cycle, all the people involved in building a software. We will see all the tools required, and so on and so forth. So let's get started. In this case, I created an example, which is Antica, Pizzeria Napoletana. If you like pizza, that's the perfect video for you. So let's say that we have 100 stores around Italy. I imagine this like a fast food for pizza, let's say McDonald's, but for pizza, just pizza. You can have all the types of pizza, and we need all the IT infrastructure on top. So we are not just talking about a simple website, we are talking about the entire IT infrastructure. So back office, I don't know, all the systems that needs to be in place to manage 100 stores, everything basically. So this is our customer. Usually when you start a project like that, when you are the business owner, you have mainly two choices, more or less. First choice, you have to create your own internal team of software engineers, designers, product managers, and so on and so forth. The second one is to hire a consultancy company. If you don't know that, I work for a consultancy company called Nearform. Check it out on Google. But by the way, you can ask a consultancy company to build your own software. So the consultants will help you to build your software, or will build totally the software, and then we'll take care of the maintenance, running it, and so on. But let's say that we are in the first case. So we want to build our engineering team, our designer team, because we have 100 stores, we have a lot of business, is going great, so we want to create our internal engineering team. In this video we are not gonna cover the hiring process because I think it is slightly out of scope. What we will see is, starting from the requirements that we will see in a bit, how we can achieve a working software with security, performance, monitoring, everything which is needed for a production software today. So first things first, let's say that we have now our engineering team. We usually have the main people are usually at least, well, one CTO. Then you will have product designers. In this case, if you have a business that is working very well like this, you will probably already have some designers. Maybe your designers are an agency, or maybe they are external people. Maybe that's the time to hire someone to work full-time with your business, or you can ask your agency. Then you have developers, devs, which are the people that actually build the code, right? Then you can have a product manager, which stands for PM, or usually they are called product manager or project manager. They are two different roles, but let's say that for this project we have a product manager because we want to build a product that supports our business. Then we can have other people like DevOps engineer, DevOps, or cloud engineers, and so on and so forth. So we can have other peoples that mainly are responsible for the infrastructure side of things. But let's say that in this case, the devs are responsible for the infrastructure because maybe we use infrastructure as a code. Maybe our CTO worked really well in the past with AWS or GCP, so we have the experience and we have the skills to do it by ourselves. So we don't need other people full-time doing that. All right, now that we have our team of people, usually the size of the team, of course, depends a lot on the size of the project, but as a rule of thumb, we have this 2 pizza team, which is fun since we are a pizzeria. And by 2 pizza team, we mean not Italian pizza, but American pizza, where you have these huge pizzas and you just take a couple of slides and you are full. Usually the number of people involved in this team is from, let's say, 3 to 8 people. You shouldn't have more than 8 people on a single team because else you are gonna have a lot of communication overhead. In that case, it is probably better to split one team into two teams. They work separately, and then you have, for example, the CTO or one of the most senior devs that act as a bridge between those two teams. Okay, let me remove all this stuff from here. Now that we have the team, let's get started by getting the requirements from the business. So requirements. Okay. So we actually need to know what to build, right? We have the team, we know what the people are that are involved, we need to gather our requirements. So we say that we have 100 stores around Italy and we want to create our booking system. So booking system. We want to create our front store. So let's say store. And we want to create connections for Deliveroo and Just Eat and so on. So connections with third-party apps. Okay. Then we want to create an internal system, a back office that helps me as a business owner to understand the main metrics of my businesses, the metrics for each store. So let's say that the Milan store is outperforming the Rome store. So in that case, let's see why it is outperforming. Let's gather some metrics. So this is a really important thing, and we will call it back office. As you can see here, we have something like 4 main projects for streamline of work. For each main project, we will have other requirements. So for example, what are the requirements for the booking system? What are the requirements for the store? Shall I don't know, sell stuff through the store, or is just a front for the user and they can see how beautiful my pizza are and this kind of things? It really depends, right? So as a CTO, I work together with the PM and with the business owners, and I ask them some clarifying questions like, okay, what are you expecting to see from this product or from this project that we are building? Once you have all the information, usually you need at least one place to collect everything, because of course all this stuff cannot stay into your mind. We have a lot of people involved here, so we need something written, usually. Written. All right. Okay, what tools can we use to have this written communication? Well, first of all, I'm a big fan of Notion, so we can use Notion, first of all. I just want the logo. Okay, cool. And we can copy it, and we can go here. Or even we can have the Google Docs logo. Or we can use, you know, everything that helps us to write down things. Like Office, Microsoft Word, whatever. This is really important because it helps us to keep track of the requirements, keep track of all the documents. So you need a shared space with your team, mainly the designers, developers, and everyone needs to have access to those documents because they are the key for communication. Then usually, at least in a remote environment, you will have something like Slack or Google Teams in order to communicate with people, right? So you need a communication channel. As you can see, we are not talking yet about writing code because that's probably one of the last steps. We are talking about the tools that we need for our communication internally and externally. So here we need something for team communication. Okay, and we can use Slack. Or we can use, as I said, Microsoft Teams or other tools. Okay, we have the requirements. Let's say that we wrote down the requirements. Now we have a huge list of requirements that are important for the business. Maybe they validated the requirements building an MVP. If you don't know what an MVP is a minimal viable product. Maybe they already had the website, maybe they tried a third-party booking system and it worked really well for the company, so they want to build the internal one right now. So let's say that all those assumptions are correct. Now, what is the next step? We have the requirements, we have the team, we have to start working on it. How to do that? First of all, we need another tool to manage the project, and as you may guess, they are called project management tools. You can use Notion as well, so let's call it PM tools, project management tools. And as I said, we can use Notion. I personally really like Notion because you can use it for your knowledge base, for the requirements and so on, and you can use it for the project management of your project as well. So that is a perfect tool. Or you can use Jira as well. Not sure if I pronounced it correctly, but yeah, here is the tool. Copy image. And you can use Trello, you can use GitHub as far as I know, have something like that. But it's important that you have something like a Kanban board. Yeah, if you don't know what a Kanban board is actually a board with multiple columns, and you have a lot of items or things that needs to be done. For example, let's say buying the domain called anticapizzerianapoletana.com, and you have to buy it, so you will put it in the backlog, and then someone will pick it and will be moved in doing, and then review and done, and so on and so forth. So that's one of the features of a project management tool. Of course, there are tons of other features, but let's say that we are happy just with a Kanban board. So we can use Trello, we can use other tools as well. All right, now that we are on the same page, now we have a team, requirements, we have a way to communicate using Slack, for example. We have a project management tool. The next thing is thinking about the technology selection, because we have the requirements. Let's focus, for example, on the booking system, right? So we will focus just on the booking system. We know that the booking system is a customer-facing system. So we have probably one or two pages of requirements about the booking system, how it should work. We have functional requirements and non-functional requirements as well. A functional requirement is how the booking system should behave in front of the user, and the non-functional requirement can be, for example, a performance requirement. Let's say we have to support 1000 users concurrent on the same session. So we have a lot of non-functional requirements. When you're writing a requirement document, keep in mind to ask your stakeholders the non-functional requirements. I saw a lot of projects failing because of that. So you will have accessibility, availability, compatibility requirements, a lot of requirements depending on your project. All right, based on all this stuff, it's time to do some technology selection. Usually when you do technology selection, you can go for byte or build. Sometimes if there is a commercial option, can be a really good choice to just buy what you need instead of spending countless hours building it. But sometimes it is also worth to build a custom solution if your requirements are really custom. Let's say that in this case, we evaluated the options on the market and we say, okay, this is a really specific use case. We didn't find any software at a good price that helps us, so let's build it from scratch. When we need to build it, now we have to make technology selection. We do a rough architectural diagram, so we talk about architecture. Why do we need to make an architectural diagram? It is really useful because it helps us to streamline down what are the tools, the software tools that we require. So do we need a database? Do we need a file system? Do we need a caching layer? What are the tools that we need from the architecture point of view. Once we have all that, we think about, okay, what are the technologies that we can involve? So we need a database, cool, what type of database? Do we need a relational database or we need a NoSQL database? It really depends on the use case, right? Okay, that's a lot of stuff, and we are not writing code yet. That's really fun. We made a lot of things and we are preparing for the project, but right now we have 0 lines of code written. All right. Usually these architectural diagrams can be made on diagrams.net. Diagrams.net. Let's find the logo. Should be this one. Yeah, it's good enough. But of course, there are a lot of tools out there. You can use the tool that you prefer. Okay, now that we have an architecture, we need to choose our technologies. Let's say that our architecture is a really simple 3-tier architecture. So we have a front-end layer. So this is our user, which interacts with our front end, and then the front end interacts with the back end. Oh, I'm really sorry for that. I have no idea how to draw diagrams with this pen, but it's really fun. And then we have data layer like a database. Okay, that's really simple. In case of the front end, we want to choose a front-end framework, but what front-end framework shall we choose? We have React, we have Angular, we have a lot of them. So let's say that we want to go with Svelte or React logo instead, or Quick or Angular. Yeah, we have a lot of them. But of course, in this case, the choice of the framework depends a lot on our application, and in this case it also depends on the skills of our team. So let's say that we want to use React. We have to keep in mind the skills of our developers, but we also need to keep in mind what we need to build. If React is a good use case for our tool and our developers know it, let's go for it. Let's suppose that this is the case, so we want to use React for the front end. Let me add here the logo. Okay. Now we need to build our backend layer. So let's say that we have our APIs. I want to build, for example, an API layer using, I don't know, let's say that our developers are using Node.js, so they would probably use something like Fastify logo. If you don't know Fastify, just check it out. It's an awesome tool for creating APIs and everything related to Node.js servers, and it works very well. So we will have Fastify, then we will have some REST APIs here in the middle, or GraphQL or TRCP, it really depends. But let's say that we have React, that we have Fastify, then we want to have something on the backend. Maybe we can have a database like Postgres, SQL. No, I'm looking for the logo. Okay, so let's take this one. No, I don't want to save it. I just want to copy it. Okay, cool. Oh, that's huge. That's huge, like an elephant. All right. So we have our technology stack. That's great. Now it's time to code. Finally, we can write our first line of code. We start usually by initializing the project. In this case, I think it's okay to create a monorepo. It really depends. If you want to use or not a monorepo, it really depends on the case, but let's say that in this case we want to use a Lerna monorepo. I just want to get the Lerna logo. That's a really minimal logo. I'm just kidding, but it's fine. So we will have a monorepo here, and inside the monorepo we will have all the code that we need. Monorepo. Okay, cool. We have our monorepo. We have to use some version control, so we will use probably Git. Well, Git is like the standard nowadays, so let's use Git for sure. If you don't know what code versioning is actually a way to save all the versions of your code. So let's say that we have our React component. We want to keep track of all the changes in our React component, or we want to keep track of whether I add a new component or remove an old one. So with Git, we can do all this stuff, and we can have multiple branches as well, which is quite useful when multiple developers are working on the same code base, but we will see it later. So we have Git with our Lerna monorepo, and we need probably something like GitHub to host our project. Okay. As you can see in this video, we are also focused a lot on the real tools that we are gonna use. Okay, so what happens when one developer starts to write some code? Let's say that we have our architecture that we need to follow, we have our requirements, we have our Kanban board. First things first, the project manager or product manager, usually with the developers and the designers, creates something like stories. If you are familiar with Scrum, you already know what I'm talking about, but if you are not familiar with Scrum, let's say that a story is a requirement from the point of view of the user. So as a user, I want to be able to log in into the system through Google Authentication. This is an example of story. The stories goes into the backlog, and then one developer will pick the story, put it in doing, work on it, and once it's done, we'll go on review for the Q&A or testing, and we will see it in a bit. Once it's finished, boom, it's done, it is on production, and we are all happy. Of course, it's not that simple. And now we will see all the processes from this Kanban board perspective. Okay, let me pick another Kanban board here, and we will see now in detail all the steps that happens. So we have our backlog. Good. Okay, let me make this login example. So here inside the backlog, we will have something like the login user story. Good. As a developer, I read this user story. I decided to pick it. So here from backlog, we'll go in doing. When I start to work on it, what I do usually, each item, each task has its own ID. So that's my workflow, but it really depends on your company and on your team and how you work generally. But what I do, I create a branch called, for example, task/ID, and then a semantic ID like login in this case. I create the branch on the repository. I start working on it. So let's say I create my React components, the page for the login. Then I create the routes on Fastify that I need. So let's say the login route, something that returns me like a JWT. And then I can also do a check on the database. So it really depends on how I want to implement the login, or if I want, I can implement something like SSO, but it really depends on what is written inside the user story. Once I am happy with the result, what happens is that I do a commit, or I do multiple commits over this branch. Once I'm happy, I create a PR on GitHub, PR, which stands for pull request on GitHub, and I ask to my team actually to review my PR. So I say, hey folks, you can send a message on Slack, or you can have even automations. I say, hey folks, I finished to work on this stuff. So here in the Kanban board, from going, I move it to review required, because I'm requiring you to make a review. I can say here in the description of the PR, hey folks, I implemented the login function as required into this task, and I link maybe the task on the Kanban board. So we are in review required. What happens here is that at least one person must make you a review. And what can happen is that they either accept, never happens. So they can accept your pull request and they can say, hey, you know what? Good job, looks good to me. We can merge it on main, or we can merge it on whatever branch. Or they can ask for changes, so require changes. Okay, and they can say you, okay, that's good, but we can improve it in this way, or here you used this anti-pattern, please let's fix it, or I don't know, you are not following our guidelines in some way, let's fix it. But please keep in mind, if you are doing a code review, don't be a jerk, please. Or third option, which can happen, is that it is closed. Let's say that you implemented the login in a very wrong way, or maybe you misunderstood the requirement, or maybe the team is for some reason still evaluating if they want to implement the login in this way or the other way around. It can happen that sometimes your PRs are just closed. This doesn't mean that you wasted your time, because maybe it can be part of a discussion, but sometimes just happens that the PRs are closed and not merged. Once I am here in changes requested, I can apply the changes that are requested, or I can continue the discussion. Let's say that someone requested me to change the route name. I can argue and say, hey, I think the route name is okay. And then in that case, we usually talk to the product manager and the other people inside the team. And we say, okay, let's evaluate what's the best route name. This cycle repeats until we go to the accepted status. Now, what happens when we accept a pull request? What happens usually is that the CI/CD pipeline is triggered. A CI/CD pipeline is usually responsible for a lot of things, but usually what you have is that here you have your code, here there are some steps, and here your code is finally on production or on staging or the other environments. So it really depends. What are the steps? It is configurable. You can choose what steps you need. Let's say that you want to have something like lint in order to check potential linting issues. Then you want to build. Then you want to run the tests. And then if everything goes well, you want to deploy. How can we create this CI/CD pipeline? Well, in case of GitHub, we can use GitHub Actions. Do we have a logo for GitHub Actions? Oh, cool. So let's assume that we are using GitHub Actions. So what happens is that we create usually a YAML file. We do the linting step, we do the building step, we do the testing, and then we deploy. All right, we talked about a lot of things. Just let me do a step back, because we are talking about code, we are talking about developers, but we are not talking yet about designers and what happens from the designer point of view. I'm not a designer myself, so I'm sorry, designer folks, if I will say a lot of bullshit, but I will just tell my experience and my point of view of how developers can interact with designers. So usually, designers use slightly different tools. They don't use code 99% of the time. They usually use Figma. Logo, I need the logo here, okay. So they also have their own task, of course. They also have their own Kanban board, but their work is slightly different, because as an engineer, we know what to do. Usually we know how to do it. But from their point of view is slightly different. So they do a lot of research, they do a lot of evaluation, they test multiple options, they do a lot of prototyping, and then once they test a bunch of different designs and a bunch of different things, they evaluate with you, with the developer, with the product manager, what is the best option, and they give you as an artifact usually a bunch of designs, components, tokens, statuses, and prototypes. So that's what happens from the designer point of view. Then, as a developer, I need to know at least the basics of Figma. I go on Figma, I check the wireframe or I check the mockup that has been generated from the designers, and I use that one as a starting point to build my UI using React in this case. Of course, designers have a lot of other tools. For example, they can use MyRobots, they can use Whimsical, they can use a lot of stuff depending on your use case. So as you can see for now, and we just scratched the surface here, writing code is just a tiny part of the software development process. We didn't talk yet about testing, we didn't talk yet about infrastructure, and we will see something, at least I hope. We didn't talk about manual Q&A, so there are a lot of topics that we should cover when you talk about software development. It is not just reading some stuff on the requirement document, writing some code, shipping to production, and it's done. Unfortunately, it's not that simple. But let's go just for a moment to the test step, because we say that we have this CI/CD pipeline. Inside the CI/CD pipeline, we will have the linting, the building, the testing, and the deployment. In the case of a web app, usually we have multiple types of tests. And of course, we have to write tests. If you are not writing tests, start now, please. If you don't write tests, you are a really bad developer, to be honest. Or maybe depending on your context, you don't have time to write tests because the business is pushing. In that case, educate your business side of things and tell them that testing is important. By the way, we have unit test, we have integration test, we have end-to-end test, end-to-end, and we have other types of tests like load testing, performance testing, accessibility, so everything else. Unfortunately, here we can only scratch the surface because testing is a huge topic. But for me, one of the important things is understand what to test. Some people think that having 90% or 100% test coverage is the baseline or is at least useful. I don't think so. I think that tests are so useful, but you have to test the right things in the right order, and you have to give to your tests the right priority, because of course, in an ideal world, we will test almost everything, but we don't have the budget and the time to test everything. So we need to reduce the number of tests to the bare minimum, and we need to get the most from all the tests that we're making. Of course, we are talking here about automatic testing, but we will also have some manual Q&A to do. Talking about, for example, end-to-end testing, you can use tools like Cypress, Logo, or even Playwright. It really depends. But if we are talking about end-to-end test, I think that Cypress is a really good choice right now. Or as I said, even Playwright is fine. Let's move for a second about the deployment, so all the infrastructure that we need. What we have now is a code that is running locally, and we have our CI/CD pipeline, but is breaking when we go here because we have actually an empty deployment status. So we cannot yet deploy all this stuff. How we can deploy our application? Usually, you deploy your application to an environment. Of course, we all have our main environment, which is called the production environment, and it is the environment that all the users see. So let's say that I'm a customer of this application, of this booking solution. When I go, for example, to anticapizzerianapoletana.it/booking or whatever, I will see the production version of the application. But we also have other environments, let's say a testing environment, a staging environment, a canary environment with, I don't know, new features. We can have as much environments as we want, or we can even have an environment for each team, or even an environment for each branch, if that is useful in your case. That being said, we can deploy usually. Nowadays, you can deploy on-premise or on cloud. Let's say that we want to deploy on cloud. Then we need to go back to the technology selection and we need to choose what cloud vendor to use. So we have, for example, AWS, we can have Azure, and we can have Google Cloud Platform, so GCP. It really depends. Let's say that in this case we are happy with AWS because maybe our CTO used AWS in the past, and we will go with AWS. So let's pick the logo here. Of course, we need to evaluate what cloud provider to use. In this case, we are just using AWS as an example. All right, now on the AWS side, what we need to do, we need to provision all the resources that we need. We say that our application in this case is fairly simple. So we have a front end, we have a back end, and we have a database. On the AWS side of things, we need to do the resource provisioning. So what we need to do in the case of the database, we need to choose what database offered from AWS we want to pick. Let's say that in this case I want to pick Aurora from AWS, and we will host our front end on Amplify. And then maybe for our backend we can use, I don't know, ECS. How do you know all this stuff? How do you know the AWS services? You have to study, actually. That's why a lot of companies have their own cloud architect or their DevOps engineers. That's because the cloud nowadays is so complex. There are, for example, just on AWS, there are more than 200 services. So it is a really huge amount of services, and you also need to keep yourself updated. But let's say that you know AWS, you know that you need an Aurora cluster, you know that you need to deploy your front end through Amplify, and you want to deploy your backend through ACS. If you have just one environment, maybe it is fine to deploy all this stuff manually, and then you set up your CI/CD pipeline to auto-deploy all this stuff. But usually, as a best practice, when you have a slightly more complex architecture, is always better nowadays to use infrastructure as a code. So infrastructure as a code. Some tools are, for example, CloudFormation directly from AWS, or even using Terraform. So let's pick the Terraform logo. They work slightly differently. So if you want to understand how they works, just take a look online. Basically, CloudFormation works just for AWS, while Terraform is something more abstract, and then you have like connectors, in this case for AWS. Let's say that our linting is passing, the build is passing, the testing is passing, the deploy is passing because we created our infrastructure so we can deploy stuff on our infrastructure. We have our login feature finally, and we can move it on done. Good job! You just finished your first story in this fairly simple project. Of course, bigger projects will have multiple teams, a lot of stakeholders, a lot of more technology involved. You will have complex decisions to make. You will have more complex architectural diagrams, and that's why I really love our job. If you are passionate about software engineering, you will study for the rest of your life, because there are so many things that you can learn. There are so many technologies that you can use, and as far as I can see, it is going faster and faster. So if you want to become a software developer, now that's the perfect moment for you. Probably this video has been slightly longer than usual, but hey, I had a lot of fun. I hope you enjoyed, and if you have any question about all this stuff, or if you want any customized advice, just write me on LinkedIn. I will be more than happy to spend half an hour with you. So thanks a lot for watching this video, and I will see you in the next one. Cheers!